You ever wonder how historians can trace an idea across, centuries? How can they prove that one ancient writer borrowed from another, especially when they didn't just copy and paste? Well, today, we're diving into a really powerful tool for digital humanities called SimpleKG. It's designed to hunt down those exact kinds of hidden connections buried inside massive collections of texts.
All right, so here's our roadmap for today. First, we'll get into the weeds on the big problem that keeps historians up at night. Then, we're going to pop the hood and see how SimpleKG takes messy, raw text and turns it into a clean, structured graph. We'll also see how you can tweak it for totally different fields. We're talking everything from ancient history to modern law. And finally, we'll see how it creates a kind of universal translator for ideas, which is the key to spotting those hidden links between texts.
So, here's the core challenge, right? For anyone studying old texts, you're trying to track how ideas move around. But authors don't just quote each other. They paraphrase, they summarize, they translate. This means they're sharing the same facts and concepts, but they're not using the same words. And that makes a simple keyword search, well, pretty much useless.
Okay, look at this. It's a perfect example. Text A says, after Simon died, his son Hyrcanus succeeded him. Text B phrases it as, the leadership was taken up by his heir Hyrcanus. Now, you and I can see instantly that they're saying the exact same thing. But a computer, it just sees a jumble of different words. It has no idea that the underlying meaning is identical. And this is the exact problem SimpleKG was built to crack.
And this is where SimpleKG completely changes the game. It stops trying to match words and instead starts comparing the actual structure of the knowledge. It pulls out the key players, the Simon and the Hyrcanus, and the relationships connecting them, like succeeded. It basically translates messy human language into a clean map of facts, so we can compare the facts themselves, not just the words used to describe them.
So how does it pull this off? You can think of the whole process like a digital assembly line. We feed raw text in one end, and it goes through a series of stations where it gets broken down, analyzed, and structured until a beautiful, clean knowledge graph pops out the other side. Let's actually follow a sentence through this pipeline.
We're going to use this sentence right here from the ancient historian Eusebius as our little guinea pig. We're going to watch what happens to it at every single stage of the SimpleKG process.
And just so we're all on the same page, this is our end goal, a knowledge graph, or KG. Seriously, just think of it as a map of facts. The dots on the map are the key things, people, places, events. And the lines connecting those dots, those are the relationships between them. Simple as that.
So here's that assembly line, step by step. First, it chops up long texts into smaller, bite-sized pieces. Then, it goes hunting for all the potential key terms, the nouns really. After that, it gets smart, adding context and categories to those terms. Then it figures out how all those concepts are connected to each other. And finally, it stitches everything back together into one big, unified graph for the whole document.
Okay, but here's a huge question. How can one tool possibly understand both ancient Greek history and a modern legal contract? I mean, the language, the concepts, they're worlds apart. Well, the answer is in this incredibly clever, almost plug-and-play design.
The secret sauce here is something called a DSP signature. It's brilliant. Instead of writing a bunch of complicated code to tell the AI how to find things, you just give it a simple mission briefing. You tell it what you want. For example, find me all the rulers in the kingdoms they ruled. You don't tell it how to do it. You let the large language model figure out the best strategy. This makes the whole thing unbelievably flexible.
And because of that, you get this. The core pipeline, that assembly line, it never changes. You just swap out the instruction manual, the signature registry, depending on your project. Analyzing ancient texts, plug in the Greek one. Working with legal docs, pop in the legal registry. It's this modular approach that lets it handle pretty much any kind of text you throw at it.
Okay, so we can build graphs for any text. That's cool. But to actually compare them, we hit another snag. What if one text says someone ruled over a city, and another says they governed it? We need everyone to speak the same language. And that's exactly what ontology normalization is for.
And you can see exactly what that looks like right here. On the left, you've got the raw output. It's a little messy, using the exact phrasing from the text. But on the right, it's been cleaned up and standardized. Ruled over is now ruled over, succeeded is now succeeds. This little step is absolutely crucial because it means we're always comparing apples to apples across our entire library.
And SimpleKG is really smart about this. It uses a two-layer system. It's kind of like a belt and suspenders approach. First, it gives the AI a cheat sheet, telling it to try and use the standard terms from the get-go. But then it runs a final check afterwards to catch any mistakes and force everything to conform to the standard vocabulary. It's super robust.
So what does one of these controlled vocabularies, an ontology, actually look like? Well, here's a peek at the one for ancient Greek texts. It defines 12 standard types of things, like a person, a place, or an event, and 28 standard types of relationships, like ruled over or succeeds. This is the shared rulebook that makes meaningful comparison possible.
All right, now we get to the really good part, the payoff for all this work. We've turned our messy texts into these beautiful, standardized, comparable knowledge graphs. So, what do we do with them? Now we finally go hunting for those hidden connections across a whole universe of texts.
To make searching super fast and accurate, every single fact gets converted into a simple format called a typed triple. It's just subject, verb, object. But you'll notice it includes that one extra vital piece of info, the type of each thing. This is so the system knows that person Hyrcanus is different from, say, a place with a similar name. It adds a crucial layer of precision.
Now, you might be thinking, searching an entire library for thousands of these little facts must take forever, right? But this is where the system is just so clever. Instead of running a separate search for every single fact, it bundles them all up. It uses a hybrid search that can scan the entire corpus for all the connections you're looking for in just 2 requests. It's built for huge scale from the ground up.
And this is what it's all about. This is the final result. The system hands you a ranked list of other texts that seem to be talking about the same stuff, and it's not a black box. You get a score, sure, but more importantly, you get the proof. It shows you the exact facts, the specific triples, that your text shares with all the others. It gives you a clear, verifiable place to start your actual research.
This quote just nails it. Ontology normalization, that step of creating a shared language, is what makes the whole thing work. Without it, you're back to just comparing words. But with it, you are finally comparing the underlying facts. That is the breakthrough that unlocks true, large-scale textual analysis.
So, to boil it all down, Simple KG is a system that takes this chaotic world of varied human language and translates its essential knowledge into a single, unified, searchable structure. It's all about making that invisible web of connections between texts finally visible to the human eye.
And that really leaves us with a pretty exciting question, doesn't it? If you're a researcher who works with any large collection of documents, it has to make you wonder, what relationships, what lines of influence, what shared ideas are just sitting there, hidden in your data, waiting for a tool like this to bring them to light?
So if any of this got your gears turning, the best part is that this whole project is open source. You can install it with one simple command and start exploring your own texts right away. Thanks for joining me on this deep dive.